Hello, geometry. Sorry, let me get that straightened out. There we go. So 5.2, congruent polygons. So figures are congruent if and only if there's that key biconditional there, very powerful statement, right? If and only if a transformation, hey, we just learned about those. If a transformation maps one figure onto the other one. So corresponding, all right, corresponding sides and corresponding angles are congruent. So here we have two different triangles, triangle ABC and triangle FED. We want to figure out what their corresponding sides are, and then we're also going to write a congruency statement. All right, a congruency statement. So AB here has one tick mark. If we look at our other triangle, DE has one tick mark. So AB is congruent to DE. And then we have BC or CB has two tick marks, and FE has two tick marks. So BC is congruent to FE. And then last but never least, we've got CA or AC is congruent with three tick marks to FD. Right? So those are our corresponding sides. A, B, and DE have one tick mark, BC and FE have two, and then CA and FD have three. For corresponding angles, we're looking at our whooshies. So let's start with angle A. Angle A has one whooshie. When we look over here, angle D has one whooshie. So angle A is congruent to angle D. And then for this one, let's look at angle B with its two whooshies. It's going to be congruent to angle E, which also has two whooshies. And then angle C is our last one, and it's congruent to angle F. All right, angle C and angle F. So congruency statements. This is where we match up all of our letters so that we are writing them in the same order, so that the corresponding parts match up. I find it easiest to do this based upon the angles. So triangle ABC is congruent to triangle. A matches up with point D, B matches up with point E, and then C matches up with F. All right, so ABC is congruent to DEF. Even though they look kind of weird, that's how it rotates, so to speak, how it matches, how it corresponds. So if all pairs of corresponding angles and sides are congruent, you can write a congruence statement. So order matters. Always list the corresponding vertices in the same order. So we already did ABC to DEF. I'm just going to change this up, and we're going to do it with BCA, right? BCA corresponds to triangle EFD, right? Another way that we could, sorry, you can't see that. Another way we could write it is, because we already did ABC and DEF, now we've done EFD and BCA. So let's do ACB. So ACB. So we would do DFE. All right, those are all correct ways to write the corresponding congruency statements. All right, all of those have the corresponding vertices matching up, the corresponding parts match up, and so the order is perfect for any of those. All right, the key here is not that it's always alphabetical. The key here is that you want to match up the parts that correspond. Right? Hopefully that makes sense. It's really, really, really super important, though. All right, really, really. So for our third angle theorem here, if two angles of one triangle are congruent to two angles of another triangle, then congruent. I messed up. All right. Yeah, no, I said that, congruent. Then the corresponding pair. Oh, then the third angles are also congruent. All right, so if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are also congruent. So in this case, if A is congruent to angle D, and if B is congruent to angle E, then angle C must be congruent to angle F. This is where you go, duh. Obviously, if these match up and these match up, then these two must match up as well. Duh. All right, let's try some of these out. So we want to identify all pairs of corresponding parts. Write a different congruence statement. All right, write a different congruence statement than the one that was given. So we know, let's just start with angles. Angle J. J was the first letter, so that means the first letter is also going to be congruent. So angle J is congruent to angle T. All right. Then we know angle K. K came second, and our other triangle, it's S. So angle S. And then angle L, which is congruent to angle R. And looking at our diagrams here, we can see that as well. Right? K has 3 wooshies, S has 3 wooshies, L has 1 wooshie, R has 1 wooshie, J has 2 wooshies, T has 2 wooshies. So that also makes sense. Now when we look at sides, I like to start with the first 2 letters and just work my way through that way. So JK is the first 2 for our first triangle. In our second triangle, we have TS. So JK is congruent to TS. Then I'm going to do the next 2. So that would be KL. KL is congruent. The next 2 would be SR. And then the last one is kind of the outer one. So JL in this case, or LJ, is congruent to, and then the outer ones would be TR. And when we look at our diagrams here, we can see that that's true. JK has 1, ST has 1. KL has 2, and SR has 2. And then JL has 3, and RT has 3. So for a different congruency statement, I'm going to go with LJK. All right. LJK. So L corresponds with R. J corresponds with T. And then K corresponds with S. So triangle LJK is congruent to triangle RTS. Order matters. All right. Order matters. I want you to try this one on your own. Pretty much everything is marked except for side RT, which should be kind of a little bit of a, well, duh, it's congruent to itself. So I'm going to give you that one already. RT is congruent to RT. All right. So try that one on your own. All right, taking a look at it. Hopefully you got the angle S is congruent to angle U. Angle SRT, yes, you need 3 letters in this case, is congruent to angle UTR, and then angle STR is congruent to angle URT. So side RU is congruent to ST, and side UT is congruent to RS. 2 different congruency statements you could have would be triangle TSR is congruent to triangle RUT, or triangle STR is congruent to triangle URT. So either one of those works. All right. Down here at number 3, we want to complete the following statements. We want to match these up. So we know that triangle KPM is congruent to triangle AYC. All right. So I like to just do angles first, personally. So K and A match up. P, I'm going to give 2 wooshies to, and it goes with Y. And then M gets 3 wooshies, and it goes with C. And then I can also mark our sides. So KP is 1, PM is 2, and then I'm going to give 3 to my last side. AY is 1, YC is 2, and then 3 to our last side. If you know it, mark it. If you know it, mark it. KM is this guy right here. It has 3 wooshies, so it corresponds to side CA or AC. Doesn't matter, right? Order doesn't matter in that case. So you could have named it AC or CA. Takes us way back to chapter 1. CY has 2 Wuxis. It corresponds to PM. All right. I'm going to do this one right here with you. Angle ACY. So ACY. So that's really angle C. It has 3 Wuxis. It's going to correspond to, and you want to match them up as well. Okay, so A, that corresponds with K. C corresponds with M. So K, M, and then P. All right. So match them up, correspond them. I'm going to let you guys write your congruency statements there. And then we're going to do number 4 together. So try finishing number 3 on your own, and we'll talk about it in just 2 seconds. All right, for number 3, you should have gotten YA for PK, angle P for angle Y, angle A is congruent to angle K, and then triangle MPK is congruent to triangle CYA, and then triangle YAC is congruent to triangle PKM. If you know it, mark it, or mark it if you know it, however you want to say it, either way. If you know it, mark it. All right, for this one down here, we know that triangle STW is congruent to triangle BFN. All right, BFN. So that means that BF corresponds to ST, because those are both the first 2 letters, right? So they're in the same order. Then TW comes next, and TW corresponds to FN. And then we have SW is going to get my 3 little tick marks, which corresponds to BN. Angle S gets 1 Wuxi. It corresponds to angle B. Angle T gets 2 Wuxis. It corresponds to angle F. And then W gets 3, and so does N. So now we can pretty easily see how things measure up, how they correspond, right? So BN, for example, it's got 3 tick marks. That corresponds to 9 centimeters. If you know it, mark it. TW has 2 tick marks. It corresponds to FN, which has 2 tick marks, so it's 14 centimeters. BF has 1 tick mark. It corresponds to ST, which is 17 centimeters. For angle W right here, it's got 3 Wuxis, which corresponds to angle N, so it's 82 degrees. Angle B has 1 Wuxi. It corresponds to angle S, which is 67 degrees. And then angle F has 2 Wuxis. It corresponds to angle T, which also has 2 Wuxis. Oh no, how do we figure that out? Triangle sum theorem. Can't forget the things that we've already learned. So because we know angle B plus angle N plus angle F is equal to 180, we know angle N is 82, and we have already said that angle B is 67. So we've got 67 plus 82 plus angle F equals 180. I can solve this to figure out my missing angle F. We've got 149 plus angle F is equal to 180. So we are left with 31 degrees is equal to angle F. Because we have to subtract 149 on both sides. I skipped a little bit of algebra there, sorry. All right, I'm going to look at the next page with some more practice problems. There we go. All right, for our first one here, you want to find each missing measure. So it's just like the one we did. I will leave that one up to you. But I do want to go through number 6 together. All right, I want to go through number 6 together. Again, it's really important that you mark what you know. So we have triangle UVW. So angle U corresponds to triangle STR. So U and T correspond. V and S correspond. And then W and R correspond. Now, interestingly enough, we would say that these are acute scalene triangles. Don't forget you know how to name them. Because they all have, as we can see, they have angles that are less than 90. So these are acute scalene triangles. Remember, you know how to do this. All right, UV gets 1 tick mark. VW gets 2 tick marks, which means UW gets 3. And then TS gets 1 tick mark, SR gets 2 tick marks, and then TR is left with 3. So now I just want to set these up and set them equal to each other. This only deals with the sides. There are no angles. So I'm going to just match up my sides. UV is congruent. It's got 1 tick mark with TS. This is the setup. This is key. You must have this for 1/3 of the points on any quiz or test. All right. So I just want to tell you now, you must have this geometric statement written out. That's important. It's important to start with that. So UV is 12x minus 7. It's equal to TS, which is 53. So now I can solve this. So I get 12x is equal to 60. When I divide by 12, x equals 5. For our next one here, let's do VW. Is congruent to, it's got 2 tick marks, so it's congruent to RS. So that means that we have 57 is equal to 5y minus 33. I add 33 on both sides. 90 equals 5y. So y is equal to, I don't know why I have a hard time doing that today. I think it's 18. It is 18. All right, and then our next one is WU. You can write it UW if you want to, but go Cougs. And then WU is congruent to TR. So that would be 3z plus 14 is equal to 50. So I subtract 14 on both sides. We get 3z is equal to 36. Divide by 3, z is equal to 13. Sorry, I went into the next problem a little bit. But we know our 3, right? We know x, we know y, and now we know z. I will let you work on the last one on your own. Please email me if you have any questions.